The centuries-old question of whether we are alone has shifted from philosophical speculation into the realm of measurable data. This shift is driven by a machine operating 1.5 million kilometers from Earth. The James Webb Space Telescope possesses the precision required to detect the chemical signatures of worlds orbiting distant stars. When astronomers pointed this observatory at a world 120 light-years away called K2-18b, they found a chemical anomaly. They detected a substance that, on Earth, is primarily associated with living organisms. Despite finding a potential signature of life, the scientific community is not celebrating. Researchers are instead maintaining a state of extreme, disciplined caution. This silence is significant. It suggests that scientists are no longer debating if such a discovery is possible, but are instead focused on the rigorous verification required to confirm it. Webb does not take traditional photographs of these distant worlds. Instead, it uses transmission spectroscopy, a method of reading the light filtered through a planet's air. As a planet passes in front of its star, the starlight travels through the planet's atmosphere. Different gases absorb specific wavelengths, leaving dark bands in the resulting spectrum. These bands act as chemical fingerprints. Carbon dioxide, methane, and water vapor each write their name in the light, allowing us to identify the composition of a distant atmosphere. This technology allows us to chemically analyze the air of a distant world, a world that would take over 100,000 years to reach with our current fastest spacecraft. The spectrum of K2-18b revealed carbon dioxide and methane, as expected, but it also showed traces of dimethyl sulfide, or DMS. On Earth, DMS has one primary source. It is a byproduct of metabolism produced by marine life, specifically microscopic phytoplankton in the oceans. The data suggests that the concentration of DMS on K2-18b could be thousands of times stronger than what we find in Earth's own atmosphere. In the language of astrobiology, a signal this strong is not a subtle hint. It is a massive chemical flag, potentially marking the presence of a biological process visible from space. This observation sits at a 3 sigma level of statistical significance, meaning a 0.3% probability of random error. While newsworthy, science requires a 5 sigma threshold, a mere 0.06% probability of error, for a confirmed discovery, a level not yet reached. However, Webb has a history of providing data that challenges existing models, such as its direct observation of clouds made of vaporized rock on the planet WASP-94ab. In cosmology, the telescope identified massive, structured galaxies existing just a few 100 million years after the Big Bang, structures far more developed than models predicted. As Webb continues to provide evidence that revises our understanding of physics and planetary weather, the assumption that Earth is the sole host of biology is the next logical model to be tested by the data. Research groups are currently debating the K2-18b data, running simulations to determine if the signal could be explained by non-biological chemistry or atmospheric noise. If the signal survives the scrutiny and reaches the 5 sigma threshold, we will have scientific certainty that life exists beyond our solar system. Such a discovery would mirror the Copernican revolution, which moved Earth from the center of the solar system. It would also follow the Darwinian revolution, which connected humanity to the broader biological history of life on Earth. Finding that biology can emerge on a world 120 light-years away would suggest that life is not an earthbound miracle, but a predictable outcome of the right chemical conditions occurring throughout the cosmos. The search for life has entered a technical phase. The primary obstacles are no longer matters of philosophy, but of observing time and engineering precision. We are waiting for the computational power and the data accumulation necessary to separate the signal from the noise. The light from K2-18b has already reached our instruments. We are simply waiting for the analysis to cross the threshold of certainty.